So on page 6, we were told that these are all the times spent traveling to work in minutes. So every single number represents how long did it take you to go to work on a particular day. And so we arrange it. If I ask you to arrange it, your best bet is to grab your calculator, okay? Type in these values into your calculator. Then you go sort, ascending, sort it on your calculator, and then actually write down. So you bring your calculator to you like this. You go back to L1, and then write the numbers down in order. If I ever ask you to do that, please don't just go off of the list, because you probably miss one or you make a mistake, right? So let your calculator do the calculator is your assistant, right? So use it. Determine the mean, median, and mode. I will just show you here what I did on the answer key. So to sort it, obviously we just go sort ascending. If you go sort D, it's going to be in descending order, meaning from the largest to the smallest. That's all. As long as you're sorted, I don't really care. Determine the mean, median, mode. We've determined that, right, using our calculator. So remember, this is not exactly what you're going to see, but if you ever do the one variable statistics, remember that first number is our mean. That's our standard deviation. That's the number of elements that are, or values we're considering. That's your median, right? So those are the things that you want to know. The min and the max, you also want to know that. That's all right there, just a few clicks away. So you got your mean, your median, and your mode traveling times. Okay, and you notice that the mode is significantly different than your mean and your median. That's just an observation here that I'm making. C asked you for a standard deviation and range. Maybe I didn't ask it. Let me see if I updated yours. Yes, I did. Okay. So I inserted C there. So standard deviation and range, it is there as well. There's quite of a range, right, between the traveling times. Like it's 102 minutes difference from the shortest traveling time to the longest traveling time. Are there any outliers? And sometimes the outliers aren't quite apparent unless you make your line plots. But I would argue this one was very obvious, right, that the outlier would be 105 minutes. 105 minutes would be an outlier. It varies greatly from the general trend. Some of you might say, well, this one is also outside, but it's not as significant as this one. So in this case, the best answer would be to say 105. Remember your line plots. These numbers down here will be up to you if there's nothing given. So you have to come up with some sort of scale. Look at your lowest value. Look at your greatest value, right? The min and the max will tell you what should I spread out by. And then decide what you want to go up with, okay? And remember to label your MCTs. All right, that's it for page 6. Page 7, here's where I want you to, because you're actually going to do one with more than just 2 brands that we're comparing. But notice what I did here. We're comparing the lifespan of batteries. So there's brand X and brand Y. And here are all the years of various batteries, like how long they lasted, right? Both sides have 30. But notice what I did here. If you look up, I don't know if you did this work, you will know what I'm talking about. If you're comparing, it's good to put one of them into L1, put the next one into L2, all of those values into L2. And if there were more, you would go L3, L4, and so forth. And then to answer the mean, median, mode, and all of that of the first brand, I use L1 here, and I find the mean, median, mode, and all that, standard deviation. When I want to figure out everything for brand Y, I go one variable stats, but now I will feed it L2. Okay, and then it's just a little faster because sometimes if you need to go back, then it's easier to just have all the numbers in your L1 and L2 and so forth. And so just by observation, right away, we look at our data and we look at the mean. The overall lifespan is about the same. It's very close. So you're like, oh, if we forget about all the other data points, that we were like, oh, they're about the same, right? They're about the same. No big deal. By X or Y, it doesn't matter. But if you dig a little deeper, your median is also it's actually exactly the same. What is the median again? The middle of our data set. Specifically, the median tells us that if you look up here, half of our batteries will be lasting less than 5.75 years, and half of them will last longer than that. Okay, so that's what the median tells us. But here's where things start to change. When you look at the standard deviation, one is 1.22 years, one is 0.64 years. Okay, what's happening here? This is telling us that the lifespans we've collected are spread out more. They vary more than this one. Okay, so there's something that as a buyer, I would be like, wait a minute, this seems to be a little inconsistent here. I will rather go with this one because it has, the standard deviation is lower, which means that most of my batteries will indeed be around the 5.72 year mark. Here, a lot of the batteries will be further away from my mean. Okay, so that's kind of what I'm trying to look for here. The range verifies it. Look, a greater range, right, means it's more spread out, which is, these are like hand in hand. These ones say the same thing. Okay, and here is the range, standard deviation and range for the other one, which is half, right? Mode, we've got 5.7 years, 5.9 years. It showed up 3 times, the 5.7. I bet you 5.9 showed up 2 times? No, it says 3 times as well. For 1, 2, 3. 3 times minimum, but you don't have to. I don't really care about you telling me how many times it showed up as long as you get the right mode. And N, what does N mean? I do ask this on a test, okay? What does N mean in this scenario? The number of batteries, not the number of years, it's the number of batteries, right? So when we're talking a bunch of students and their marks, what they got on tests, N is the number of students, okay? So you just have to kind of see what are we collecting, what does each number represent. All right, 8. Page 8, we use what we've learned, and it was a lot of work. If you did this, I commend you for doing that. We're supposed to create line plots for each one of them. Okay. So again, look at up here. I'm kind of making a little note that for the first brand X, my highest is 8.2 and the lowest is 3.1. So I went from 1 to 10, right? And then I went through my list and I put a dot down every time, right, a battery fell within that lifespan. And I have my mode stacked 3 times. I have everything here that I need. I have the label, brand X. Probably lifespan would have been a good one, but it's in years. And then I did the same thing for brand Y. Okay? Good morning. Brand Y, can you tell that it's more clustered, right? If you do this right, you should see it. I'm just going to ask you this. If you're comparing, please use the same scale. It'll just make it so much easier to see what's happening. If you use different scales, it will be harder to see. So it confirms what we already knew, but this is, I need you to know how to do a line plot. And I'm not going to AC you today, but it's coming your way. So I just want to cover a little bit more ground. And so now it's time to talk about it. So when you want to talk about using statistical terms, I use the mean, the range, and the standard deviation quite often. So you can talk about one brand over the other. That is probably a bit easier to just focus on one brand. So brand X, slightly greater mean, and this key isn't the greatest. I should have, is this the key that I posted? I'm not too happy about it. Slightly greater mean, indicating a longer lifespan, right? That, like, tell me what you observe. Oh, the mean is greater. Perfect. What does that tell us in this scenario? A longer lifespan. Okay? If we're talking test scores, if somebody has a higher mean, it tells us that that person normally overall scores higher. Okay? That's what you would say there. A greater range, it tells us that it's the inconsistent lifespans, they're spread out. A greater standard deviation tells us the same thing. Data is more spread out, inconsistent. They're basically the same thing. You can toss around the words between them. Okay. If you wanted to talk about brand Y instead, you say, I noticed that when I look at brand Y, it has a lower average lifespan. How do I know this? Due to the lower mean. That's how I know that it has a lower average lifespan compared to X. Has a smaller range, which means it gives me more consistent lifespans. Has a smaller standard deviation. Data is clustered. I like to say clustered around the mean. Data is clustered around the mean. Which brand would you recommend? I would recommend brand Y, since it is more reliable, more consistent, and I know this because of the lower standard deviation. I'm going to be a bit, so those of you who did the homework, you get to add some words here. The overall lifespan is very similar, is very close to brand Y. Sorry, brand X. The overall lifespan is very close to brand X. So that is not a point of contention. Like, I'm not worrying about the overall lifespan because it's so close. Both of them are so close. That's not a big deal to me. Because what if brand X had a lifespan, overall lifespan that's like 20 years? Right? Brand X had a lifespan of 20 years instead of 5.72. Now you might actually want to say, well, for me personally, I like that overall there's a longer lifespan, which is like 4 times as much as brand Y. I might want to go with brand X, right? Because of that huge difference in overall lifespans. But if all else is kind of the same, you're going to want to go with a lower standard deviation, okay? What else should you consider? Obviously the price. What is the warranty? Customer service, reliability, anything like that, obviously we would consider as well. But most of the time we want to stick to statistical terms. All right, so that's page 8. That's all I assigned, right? I didn't go 9. Okay. So there are various, I think this is supposed to be basketball players. And so we've collected data over 10 games for each player. So I want you to figure out, for Anna, I want you to figure out her range in terms of her scores, the mean score, and the standard deviation. So basically, I would like you to place all the data points for Anna into L1, all the ones for Patrice into L2, Morgan L3, Paige L4, Star L5. Okay? And then figure out the range, mean, and standard deviation for each player, and then we'll answer the questions below. I would like you to at least think about the questions already. Don't just wait for me. The questions that follow underneath, I would kind of expect you to already know how to do those. But you can wait for me to actually answer it properly. So if you want like an answer that is kind of like concise, I will be giving that to you, okay? So go to town. Answers with or without sorting. All right. So I think I just want you to, this is what the main point I want you to get out of this activity, is that as a coach, you're looking for the player that scores the highest in terms of points, but has the lowest standard deviation. That is your best combination. Try to find a player that scores high and has the lowest standard deviation. Like that's the best combo you can have. So that's what I will be ultimately looking for here. And if you want to, it says which player would be considered most consistent? Which player is the least consistent? Explain how you know. So if you want to write this down, or if you already have an answer and you're happy with it, but most consistent would be Paige, right? Because Paige has the lowest standard deviation. Also the lowest standard deviation and lowest range. Okay, so since her range and standard deviation is low, or is the lowest, I should say. The lowest. That's why I know that she's the most consistent. Okay, least consistent is Morgan. Morgan has a range of 29 and the highest standard deviation compared to all the other players, since her range and standard deviation is the highest, or are the highest, I should say, because we're doing range and standard deviation, are the highest. Okay. Identify the player with the greatest average score. Would you consider her the best player? So we look at the greatest score of all of them. It's actually Anna has the highest overall score, not by much, but Anna is the highest scoring when it comes to the average. So Anna has the highest mean score, which tells us that on average, she does better than the rest, okay? I would not consider her the best player since her standard deviation is a little high, right? So that means it's not as consistent. And how did I know that? How do I think that that's a bit of a high standard deviation? Well, just look at all the other standard deviations, right? The lowest is 0.83, then it's 1.5, then it's 3.35, then it's 5.88. So Anna's not very consistent compared to the rest of the players, right? So not necessarily the best player in this roster, okay? I know that's subjective sometimes, who is the best player, right? But which player has the potential to score the least amount of points on any given game? Which player has the potential to score the most points on any given game? Potential for least would be Morgan, since her lowest score is 19. Okay, so if you look at the previous score here, out of all of the scores, 19 is the lowest. So this is where sorting would have probably been a good idea, to sort all of your L's. And then you would have seen which one has like the lowest, which column has the lowest number to start off with. And that would be Morgan. And Morgan is also the one that has the potential to score the highest, since she scored 48 points in a game. So she scored the lowest and the highest. Okay? Morgan has both extremes, which is reflected in her high standard deviation. Sorry, you can't see that, can you? Trying to put so Morgan has both extremes, which is reflected in her high standard deviation. So like having both extremes on both ends really spreads your results. Okay? If you were a coach, which player or players would you choose? Base your decision on what you know about the standard deviation. So as a coach, you would want to look at a player with a relatively high mean and a low standard deviation. I would choose Patrice because Patrice has the second highest average and the second lowest standard deviation. So it's one of those, like a good combo there. So she would be a good pick. And the reason I wouldn't have picked Paige, look at Paige's, let's look at, I'm going to ask you to first write this down, because I think this last one is probably the most important one. So I'm going to pause for a bit on this page. That's good. That's a good one. I'll add Paige on this page. Note, Paige has the lowest standard deviation but her overall average is the lowest. Okay, so this is a little note. If you just go by standard deviation, you might also not get it right. However, Paige is a player that you can probably improve, right? Like sometimes when they look for rookies, right? Teams look for like these players that show potential. Paige might be one of those. Like, oh, very consistent. We might just have to work on certain skills to bring up her overall average, right? So statistics is kind of fun and frustrating at the same time, okay? Because you want just this cookie cutter answer every time, and I can't give you that. So you have